Alright, we're going to look at 17.6 and 17.7, and you're going to have to use your imagination a little bit because I don't have my smartboard stuff with me right now. So, I'm going to start off with 17.6. You're going to look at precipitation and separation for ions. So these are the basic things we're going to look at here. Okay, you can achieve equilibrium by either starting with a substance as a product or one as a reactant. It doesn't make a difference. So when you have a solution that is mixed with another solution, you want to see whether your precipitate will form or not. And it's going to depend on the product of your ions that you have. Remember, we're talking about a KSP here, dealing with precipitations. So we're dealing with just the concentrations of your ions and not the concentration dealing with the solid. Remember, we don't care about the solid. So again, you're looking at either products or reactants, and in this case, we're going to look mostly at actually the products. Okay. So we're looking at a precipitate and whether or not it's going to form, and it'll form if your Q is greater than your K. And remember again that Q is the initial things, okay, and your precipitate is going to happen. It's going to continue to precipitate until they become equal. If your Q is initially equal to your KSP, then you're going to have a saturated solution, and if your Q is initially less than your KSP, then your solid is going to dissolve until your Q equals your K. So it's again back to this whole Q and K stuff that we dealt with a few chapters ago. Alright, so those are the basic things for precipitation. We're now going to look at a problem and look at what happens with our Q and our K and then whether we will get it precipitate or not. So with your problem there, it has will it precipitate form if you have 0.1 liters of that molarity of lead nitrate and if that's added to those liters of that molarity of sodium sulfate. So the first thing you got to do that I have written right there, and that highlighted one, is your reaction, lead nitrate, sodium sulfate, making lead sulfate, sodium nitrate. Well, all I care about is the lead sulfate because that is my precipitate. Remember, sodiums and nitrates are always soluble. So all I care about are those two particular ions. So my Q is the concentration of one times the concentration of the other. Okay, because looking at it from the terms of a KSP, which actually is usually written the other direction here. I usually will have my arrow going to the left with the lead sulfate on the left and this on the right, but it doesn't really matter which way you look at it. Okay, so what I gotta do is figure out my concentrations and then see how my Q compares. So I gotta figure out my moles, and from that I take my molarity times my liters, and the reason I have to figure out these two mole numbers is because your liter number changes. Even though they give me initial liters for each one, when I add them together, then you have a total different number of liters. So you got to figure out your moles first. So this 8 times 10 to the negative fourth for your lead ion is because you have 0.1 liters times 0.008 molar. And that gives you that 8 times 10 to the negative fourth. Same thing for my sulfate ion. You take your 0.4 times your 5 times 10 to the negative third, and you'll get your 2 times 10 to the negative third, or 0.002. Okay, I get my two mole numbers, divide by your total liters now that you have a solution, so the two together. I have to multiply them the two because the Q is the concentration of my lead times the concentration of my sulfate. I multiply them together and I get my 6.4 times 10 to the negative sixth. Well, I'm looking in the back of the book and it'll tell you the KSP value for PbSO4, and it will actually tell you that my Q is bigger than my K. Since my Q is bigger than the K value, it's going to precipitate, and it will continue to precipitate until the two are actually equal. If you look up the K value in the back of the book, it'll actually tell you that your KSP, I should probably put that in there, your K value is the 6.3 times 10 to the negative seventh. So that's where you're getting that the 10 to the negative sixth is bigger than 10 to the negative seventh. Alright, before you flip now, talk about selective precipitations of ions. That's where you can take an actual ion from a solution and precipitate just that one type versus many different types. You can separate them based on their solubility. So how much or how little or how well they dissolve in something. Alright, so now if I want to figure out in this practice problem, it has a solution containing some silver and some lead ions, and if I add chlorine to that solution, both AgCl and PbCl2, and they give you your KSPs there, precipitate from your solution. So what concentration of chlorine is necessary to precipitate the salt and which one precipitates first? So it's actually a lot easier than it sounds. You just have to figure out, like I have written right here in the highlight in the blue, you want to figure out, can you calculate the Cl minus ion that will be necessary to precipitate each one? And then whichever one is the lower number is the one that precipitates first, because that means you need the least amount of chlorine to actually get that to precipitate. So all you do is you calculate the two chlorine values by plugging in your numbers, and you then check and see which one's lower. So if I look for the Ag one to begin with, this is the top one, because my 1.8 times 10 to the negative 10th, that is equal to your Ag concentration, which is a 0.01, times my chlorine, and I get 1.8 times 10 to the negative 10th. I do the same thing for my lead. I have my 1.7 times 10 to the negative 5th, which is that K, equal to 0.02, which is my lead concentration, times my chlorine. Chlorine is squared, because when you break that apart, that's PbCl2, so there's two of them, so you got to square it. So I figure out that that is then 2.9 times 10 to the negative 2nd. Well, that means that this guy up here, which is my silver ion, will precipitate first, because that is the lower concentration of chlorine that's needed to get it to actual precipitate. Alright, the last thing, it deals with qualitative and quantitative analysis for metallic elements, and that's all you gotta write in your blank is what's right here. Qualitative means that you detect the presence of ions. All you're saying is it there or not? Quantitative is how much of your metal ion is there. And written there on your notes are a couple of different ways, a couple of different tests that you deal with to actually figure out whether you have an ion or not. And this is actually the lab that we will do at the very end of the year when we get done taking your AP chemistry exam. So you're going to go through and actually figure out what kind of ions you have in a solution.